Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is very similar to the previous one. The only thing, this is all not on the flat surface, not on Earth, but inside an elevator. And this elevator is going up with acceleration a, let's put it 1. And they want to find us with this acceleration the body will be moving if it's applied the force F. So they have acceleration a1 and let's say acceleration a1 equal 2 meters per second. And they want to find a. And they want to find the total acceleration if possible. So how we will solve this problem? All the steps as before. First of all, we have the outside, we have to draw a picture. Yes, this is a floor of an elevator where this body is located. And this floor, together with the elevator, is accelerating up. It may be moving down, but it's accelerating up. Moving down and accelerating up means it's decelerating, stopping, and going up with acceleration. But those are details that's not relevant. Direction of movement is not relevant. Direction of acceleration is important. Okay, so the force is horizontal and it's F. Whom else this body is interacting? Same as before, gravity, and so the mg stays the same like in the previous problem. Of course, there is a floor that pushing us up, and this is N, and there is no frictions. N is normal reaction, and that's basically it. And the total, the generic form of second law of motion is this. Sum of all forces. The first force is N, the second force is mg, the next force is F, which is given to us. And it's ma, and a is total acceleration. Unlike previous time, this is a vector sum of this component and this component. Previous time, it was all on the flat surface. That was not moving. Right now, accelerating up, plus inside the elevator, we're accelerating to the side. Okay, this is written to solve vector equation, we have to draw axes. X and Y, because everything along those lines. Fantastic. Along that line, N would be N. Oh, sorry, X is horizontal. Sorry what I'm saying. Along X, N is 0, plus mg is 0. F is positive that way, so it's exactly like before. And it is ma. And A is a component this way. This is Y, N, mg is down. F has no projection on Y, so it would be 0. It's perpendicular to this axis, so its projection of this vector on this vertical axis is 0, equal ma1. Right? So we have F equal ma, and we have, now for example, N equal ma1 plus mg. And again, there are two unknowns. One unknown is A, which can be found from this equation because F and M is given. And another is N, exactly like previous time, but we know ma1 and we know everything. So A would be exactly like before, F over M, and if 1 and 1, it would be 1 meter per second squared, exactly like before. We can find N, nobody asks about N, but what I want to say here is that this body has this acceleration, A, which is 1 meter per second. And it has vertical acceleration because it goes with the lift. And lift is accelerating up, and this is A1, and A1 is 2 meters. So you see I draw it twice as long. So actually the total acceleration will be the sum of those two projections, or the sum of those two vectors. And it would be this, this, and this. And this vector is A total. And A total is a hypotenuse in this triangular, so A total equals square root of A squared plus A1 squared. And it would be something A total if we plug the numbers here. 1 plus 4 square root of 5, square root of 5, I don't know, 2.3. 2.3 meter per second. And it's reasonable, because if this is 2 and this is 1, we add those, it should be more than either one of those, more than the longer side of this rectangular triangle. So this hypotenuse is a little bit longer, 2.3, and so it's more than that. And I hope that answers all your questions about this case. So the main idea is that acceleration in that way is absolutely not affected with what is going this way, because there is no friction. With friction it would be different. But without friction it is absolutely the same. This is independent from this, there is no connection, so we have the same number. Of course, the vector, the total vector, if they ask us, would be under the angle, because the acceleration has this component and this component. I hope you liked it. Then like, subscribe, bell, question. Thank you.